Good morning, Algebra 2. Hope you guys are doing well. So we're going to continue on with our statistics, and we're going to check out what we call conditional probability this week. Just to give you a heads up on what to expect for the next 2 weeks. This week we're going to do our lesson on conditional probability and quiz. Next week we'll do unit test, and then that will be it for us. Right? So let's jump into this. So first let's define conditional probability. So when we're given two events, A and B, conditional probability is the probability of event B occurring, knowing that event A has already occurred. Right, so the notation we use is the probability of B given A. So that's the probability of B given A. Right? So the formula for this guy looks like this. Right? In our numerator, we're going to have the probability of A and B. In our denominator, we're going to have the probability of A. Okay, so let's check out a few examples. First, we have Mitchell drew a card from a standard deck of playing cards. What is the probability that he drew a queen given that the card was red? Okay, so we have, given that the card was red, that's going to be our situation A, right? And what are the chances of a card being red? That's just going to be half the cards, right? That's 26 out of 52. Okay, and then up top, so I put that on the bottom because remember in our formula, probability of A goes in the bottom. And up top, we're going to do probability of A and B. So that is 26 out of 52. That's the chance of it being red times the chance of it being a queen. There's only 4 queens, right? So 4 out of 52. And what you'll notice, we're in a nice scenario because the 26 over 52 is on top and bottom. Those cancel. And then 4 over 52 reduces. Divide everything by 4, and you get 1 out of 13. And that's the probability that given that the card was red, what is the probability that we end up drawing a queen? You get a 1 in 13 chance. Okay, so now let's move on to number 2. We have a number from 1 to 100 is randomly selected. What is the probability that it's a perfect square given that it is an odd number? So let's do that event A first, which is given that it is an odd number. From 1 to 100, there's 50 odd numbers, right? Half of them are odd, so 50 over 100. And then up top, we have to do the probability of A and B. So given that it's odd, 50 over 100, right, times the number of perfect squares. So we got to think here. Perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. It looks like there's 10 of them, right? So that's 10 out of 100. Okay, so that's the probability of A and B. Okay, once again, these guys cancel. And then 10 over 100 we can reduce to 1 over 10. So there's a 1 over 10 chance that we get a perfect square that is an odd number. Okay. So now let's check out a few scenarios where we actually don't have to use the formula as much. It kind of helps a little bit more to actually kind of draw a little bit. We're actually going to do some Venn diagram work a little bit here. So let's read number 3. There are 62 people that take yoga class and 48 people that take spinning class at the gym. 15 people that take yoga also take spinning. If a person from these groups is selected at random, find the probability that he or she is taking a yoga class if you know they take a spinning class. So let's draw a little Venn diagram here, right? And we're going to have one side represent yoga and one spinning. Okay, so we know that 15 people are taking both of them, right? We have 15 people take yoga and also take spinning. And we know that there's 62 people total for the yoga class, so that's going to be 62 minus that 15 gives us 47. So there's going to be 47 who just take yoga. And then we do the same for spinning. 48 people total take spinning, but there's 15 who take spinning and yoga, so we do 48 minus 15, and we get 33. And now let's see what we're actually being asked. It says, find the probability that he or she is taking a yoga class if you know they take a spinning class. So in this situation, we know that there's 48 total people who take a spinning class, right? And there's 15 people that take a spinning class and a yoga class. So we would just have to do 15 over 48, which we can actually reduce because 3 goes into both of them. So divide everything by 3 and you get 5 over 16. So with that one, we didn't have to use our formula as much. Okay, so let's do one more before we practice a little bit here. Okay, so we have, of the 30 students in Mrs. Smith's math class, 13 are athletes and 9 are in band. 3 of the athletes are also in band. If one student is chosen at random, find the probability this student is in band if it is known that they are not an athlete. Okay, so a lot going on here. Let's approach it just like we did the other. Let's do a little drawing here. Okay, so one is going to represent athlete, the other is going to be band, and we know that 3 athletes are in both, right? There's 13 total athletes, so that means 13 minus the 3, well, we have 10 that are just athletes. And do the same for band. There's 9 band members, so 9 minus the 3 that do both, that'll be 6 right there. Now let's see what they're actually asking. It says, find the probability that the student is in band if it is known that they are not an athlete. Okay, so let's think about this one. We have 6 students who are in band and are not an athlete. But now we have to think about the total who are not athletes. Right, so that's going to be 30 students, and we have 13 are athletes, so 30 minus 13, we're going to have 6 out of 17 chance. Okay, so we're keeping it short and sweet today. What I want you to do to practice is flip over to the homework 3. Okay, so it's homework 3, and I want you guys to go ahead and do, let's try 1 through 9. Right. Hope you guys have a great day, and I'll see you in 2 days.